Okay, I think we're going to wait like a couple more minutes, just in case some more people arrive. But for now, we have some reminders. Homework 1 is due soon, as well as milestone 0. And for lunch, maybe I can disclose it, but we're having Subway. But don't eat Subway in the lecture hall, or else MIT will be angry. Instead, eat it outside. We will be serving Subway over there in the back. Oh, downstairs. Okay. Oh, okay. Yeah, but just don't eat in the lecture hall, and please be clean and dispose of whatever trash you have in the trash can. Okay, I guess we can get started now. Today's lecture will be about JavaScript. Oh, and also reminders, also on the blackboards here, if you need any help, go to weblab.is/questions. If you want to write on the questions doc. Otherwise, you can get help in real life on the help queue at weblab.is/queue. And also you can post on Piazza. So basically if you want to access any WebLab thing, it's likely weblab.is/that thing. Okay. I'll be presenting about JavaScript, and then Leo will be leading the workshop later on. So yesterday, as a recap, we learned about two great things. We learned about HTML and also CSS. And HTML is essentially the content and structure, while CSS is how it looks. And on the left is how HTML is written. You always have the doc type HTML, the root HTML tags, and on your right, you have the CSS rule sets. They're written in sort of like a dictionary or object-like format. Okay, and now JavaScript. It's a programming language that is all about the interaction. So it manipulates the content of a web page based off of what the user does. And it is interactive. And it's used by a lot of websites. It's what makes our website dynamic. And it is unrelated to Java. And what we like to call JavaScript is, well, when we import into the HTML document, we talked about how in the head, you can import like the title, or you can put in the title, you can import some fonts, and you can also import like styles as in the CSS style sheet, and also scripts. So what scripts refers to is the JavaScript file. Okay. And so going back to a less Mimi cartoon, not cartoon, we have that HTML is the skeleton. CSS is the skin, or what makes it look good. And then JS or JavaScript is basically what makes everything function. And how do you run JavaScript? Well, it's very browser-based. So you can go onto your browser console by following these commands and run JS from there. Or you can also create your own JavaScript file and tie it to your HTML document, which I talked about briefly before importing the script. Okay, so as an intro to JavaScript, it's very similar to a lot of other programming languages. It has types. And so it has these 5 primitive types. It has the Boolean, the number, string, null, and undefined. And a string is just like letters or characters, and a number is a number, and so on. And then for operators, it also has the main ones. You can do addition, subtraction, multiplication in any normal way, or in a normal way. And then you can also concatenate or use addition on strings because they have a built-in function for that. And you can, and what that does is that concatenates strings together. So arithmetic operators work. We also have comparison operators. We have the less than, greater than, less or equal to, and so on. One thing that is different is that there is a triple equal sign, which we will get to later. But maybe you guys can think in your head about what that might mean. Let it ruminate. And as for syntax, it's a little bit different, but also pretty similar to most of your programming languages. You have the semicolons after each line. They are not necessary, but it's good to keep your code clean. And then you also have that blocks are represented with the curly braces. And also, you can have as much white space as you want. It won't fail your code. So use that to your advantage when you want to organize it, or maybe not if you have Prettier already installed from yesterday's lecture, because that already like makes your code pretty. And you can also write comments. What I do to write comments on my Mac is command and then the slash. And yeah. comments don't affect your code, but they are what makes it more readable. So it would be really good for your partner if you wrote a comment or wrote some comments down about your function so that they know what's going on if you ever need their help. And also, JavaScript has variables. So what a variable is it's kind of a name for a value. So over here, we have the first line, let my Boolean equal true. We use the equal sign to define the variable's value. And so what we're saying is that my Boolean now has a value of true. And then we define it by, or we normally, in front of every definition of a variable, we have to put let var const, just to describe how the variable will be used. I'll touch more about this later, but let basically means that you can change your variable value at any point, and it's okay. And also to name variables, it's really good to keep it consistent. We use camel case here, and so that just means that the first word in your variable name, it's all lowercase, while the second word is capitalized and so on, or like the second, third, everything else is capitalized. Okay, now if you want to define a constant variable, so unlike let, you want it to always have the same value, you can put const in front of it. That's also one of the three key definition words that you can put in front. And this makes sure that the answer to life does not change. So it is always 6.148. Unfortunately, it did change to 6.9620, but yeah. Okay. So remember, const can change, or no, const cannot change, and let can. Okay, so a lot of you might wonder why bother using const when let exists. Like you can just use let for anything because it's less restrictive. Well, it's good to have safe coding practices. So let's say you want to make sure that const answer to life equals 6.148 does not change. Your partner doesn't know whether to change it or not. Oh, but you know that you don't want to change it. So if you just put a const in front, your partner can never change it. So it's good to keep things that don't change unchanged, and it's good to kind of bar others from being able to change it if you don't want it to change. And yeah. So like this, we don't ever want this to be changed, the seconds per minute to be 60. Yeah, you don't want certain things to change like this or conversion factors or so on and so forth. So you would put const in front. Another thing, two of the primitive data types that I mentioned before was null and undefined. They do differ a little bit. Undefined means that it is declared but not yet assigned a value, while null means it just doesn't have a value. You can think of null as being like empty. So as an example in the code below, you can see let first name is undefined because we didn't assign it anything. And then afterwards, when we change it to be something else, now it has a value. And then we can empty that value by setting it equal to null. So whenever you want to empty a value or just empty a variable, you can set it equal to null. Okay. And also let versus var. I said var very quickly that one time a few minutes ago, but we have let, var, and const. Those are ways to define variables. The difference between let and var, though, is that you should just not use it. let is just better, but if you're interested, you can Google it. It's all about scoping and also something about hoisting, which you can also Google later. Okay, and now let's say you want to test your code. You can use console.log to write to the JavaScript console. So you can put in there like 1 + 3, and you'll get 4. You can put in there like a string, and I'll output the string. And it basically works like, if you guys are familiar with Python, it works like the print function. Except now you would see this in the console. And having the console is very good for debugging. You can do like some rubber ducky testing, and it's just very good to keep in mind to know what your function is doing at some stage in its run. Okay. And then we also have alerts, and you can just put whatever string of text you want in the alerts function to make sure that this happens. So there's a pop-up from the alert, and then it's kind of like a modal, if you guys have heard of that, but it just pops up on your browser. And if you ever want to use alerts, you can do that. Okay. So does anyone have any questions about what I covered so far? Okay, great. That's good. But also good if you do have questions, to which you can go to the help queue or Piazza or questions. Okay, so now let's talk about arrays. So it functions similarly. So I'll be referencing Python a lot because I'm thinking most of you guys have dabbled in Python. So it's similar to lists. So now in arrays, you can think of it as a list of items. Now, these items don't have to be of the same type. As you can see in pets, you have a bunch of types in there, not necessarily pets, unfortunately. And you can access it by using the bracket. And so the array is 0 index. So whatever you want to access, just remember that you have to start counting from 0 from left to right. So if you want to access pets bracket 3, that would mean that flowers, the 0th position, 42 is the first, false is the second, and so bird is the 3rd position. So that's what you would get if you call pets bracket 3. And then also you can use this same scheme to define or redefine an element in the list. So over here on the bottom where it says replace, you're trying to replace the 2nd position of pets to be hamster. And so that's basically what it means when put in words. Okay. And then similarly, we have a few functions that you might have seen before. We have the pop function, which removes from the end. So it would pop out bird because bird is the last element of the array. One thing that's also cool about pop is that, well, it only returns from, or it only pops out the thing from the end, but it returns the thing from the end. So that might be useful in some cases. And similarly, if you want to add to the end, this is similar to the append function in Python list. So you can do push instead. So you would push whatever you want to add to the end of the array. Okay, and now on to conditionals. It also functions similar to Python. We have if, else, and the also statement. So it kind of means what it looks like it would mean. So it's like, oh, if the hour is less than 12, then do this. Otherwise, if the hour is less than 16, then do this, and so on. And you don't have to do indents, but it makes it a lot cleaner and more readable. And now we also have this thing called while loops. So this is important because what if we want to repeat something while a certain thing is satisfied? So for example, we want, or what this reads to be is while z is less than 1000, do this. And so it'll print out all of these things, powers of 2. And also for loops, these are similar to while loops, except now you can iterate through whatever iterator you have. And by iterator, you can think of it as the array. So over here, we have iteration to do with their indices. So we're going from the index 0 to however long pets is. And what this means is, well, it looks similar to C++ code, if you guys have heard of that for the for loop, but what the first part is, let I equal 0, it's initializing I to be 0, or our counter. And then for I less than pets.length, it's checking that every time to see if this condition is satisfied. And then I++ is shorthand for I equals I plus 1. So you're incrementing I every time in this loop. And this is what it outputs. And another way to use a for loop is the for of loop. This is a more Pythonic way. In Python, we also have a similar capability. I think it's the for in loop. And I would recommend not using this as much because you might get it confused with the for in loop subtypes, for which that just gives you a completely different thing that you want. So I would recommend iterating through indices most of the time, using for of and making sure that you're using the syntax right. But what this is basically saying is, well, instead, animal is not an index. Instead, it is a value of pets. So you're iterating through the values of your iterators, or in this case, it is your array. So it's going through all of your animals and your pets or your values, and it's printing that out. And it prints the top. Okay, now do we have any questions? We advance towards some more concepts. Yes.
What's the general difference between the parentheses and brackets?
Oh, the difference between parentheses and brackets?
Yeah. For the, why do you use brackets?
Oh, so like, do you mean the brackets around here? Okay, so how we initialize arrays is we always use brackets. And then normally you might, I think you might see like parentheses for when you're calling functions, which we'll get to later. Like suppose you have a function called add to, then you would have parentheses around it. And then also, I think in Python, we have parentheses around like a list of things. Like we can have parentheses cat, dog, guinea pig, bird, but what that's called is a tuple now. And one difference between a tuple is that it's immutable, meaning that unlike a list in Python, oh, I'm getting into Python too much, but unlike the list in Python, you can't change it. Hopefully that answers. Thank you for the question. Very good. Okay. Oh, wait, but does anyone else have any questions? Okay, nay. Well, now we'll talk about functions. So that was a good lead. How we define functions is using the equals and then this arrow thing. Oh, okay. And normally how we do it is we have we kind of define it similarly to a variable. So we still have like either the const let bar, or basically just constant let in front of the variable name for the function or the function name. And we set that equal to everything we see over there. And how that is structured is you have your parameters to your function. Normally it would be in parentheses, but since we only have one parameter, which is temp C, we don't have to, we can omit the parentheses. But usually we would have parentheses if we have multiple. And then we would have the arrow symbol, and then our curly braces to denote that everything inside of that function, or to denote everything inside of that function. And then we would always have a return statement. And so when we call that function, we use the parentheses, and then we input our argument in there. And so temp C would then be 10 in this case on the bottom. And we would just run the function as if temp C were 10. And it should output 50. And then now what's really cool is that in JavaScript, we have callback functions. And these are basically for if you want to pass around a function as if it were just any other variable. So let's say you want to call a function within a function, or a function as an argument to a function. And that would be called a callback function. So whenever we have a function as an argument to another function, we call it callback. And why would we do this? Well, in this example, we have modify array, and we see what it does is it takes in two parameters, array and callback, callback being your function, and then it goes through the array and then calls the function on each element in the array. Okay, and then add two just adds two to whatever you have. Well, now if we call modify array with the array that you have down there, 5, 10, 15, 20, and also add to the function, then now you're iterating through my array through each index, and then you are calling the add to function on each element in that array. So what this does is it adds 2 to each element in my array. So that's why you would get 5 plus 2, which is 7, 10 plus 2 is 10, or 10 plus 2, which is 12, and so on. And just to add more detail, the reason why we use callback functions is sometimes we want to reuse some capabilities or reuse some parts of a function, but we also have a bunch of variants that we want to use. So let's say we want to modify the array, but we also want to be able to modify the array and by like adding 2, or we want to add 4, or we want to multiply. Then this is a good example of using callback functions, because then we can create many functions that we can put into modify array, such that we get everything that we want. And it makes it more modularized. So it's just better that way. It's better to make sure that your code can be reusable. Okay, and then now a common mistake with callback functions is that whether you have the parentheses or not, it changes some things. So add to itself without the parentheses is a function, whereas add to parentheses x means that you're calling this function on x, which means that this returns a value when you run add to on x. And then modify array needs to have a function given to it, otherwise it won't run properly. And that's because you define the function to accept 2 values, one being the array and one being the actual callback function. So it has to have a callback function. And doing the below, does anyone know why that is wrong? Yes. That's right. It is passing in the value of what you, or it's passing what you get when you run add2 on X, not actually a function. And so that this won't work. Thank you. Okay, so we have the callback functions. And one thing to note is that in JavaScript and also in Python, you can have these things called anonymous functions. And so let's say, oh, this function add2 is pretty easy. Like, why do I even need to write a function and call it add2? Like, that might be a little bit too much work for me. Like, this is something very simple. Why do I have to go through so much work? That happens, you can just put that function in modifier array itself, because what this is called is an anonymous function. So as long as you have your arguments and then the arrow and then the curly braces, you can put that as your function to modify it, or in modifier array. And so, like I said before, if it's simple enough, you can use this shorthand. Okay. And for other built-in array functions, we have these two things called map and filter, which you guys might use a lot in your code. And so for map, what this does is kind of similar to our modifier array function that we made before. It creates a new array by applying this or some callback function to every element of the starting array. So that's actually exactly what we did in modifier array, or the modifier array function. So in this example, we input the callback function, x returns, or you get as input x, and then you return x times 3. So that's just multiplying everything by 3. So using that function, you are multiplying each element in my array by 3, which is why you get that your modified array is 3, 6, 9, 12, 15. And then similarly, we can use we also have filter. That's another function that you can use on arrays. And what this does is kind of similar to map, except you want to filter out the good things and throw away the bad things of an array. So what this does is it creates a new array by selecting elements in your original array that only pass certain tests. So in the first case, you're going through values and you're filtering, and you're only keeping those that have value greater than 0. And so that's how you can read that line. So what this does is it makes positive values to be equal to only 3, 2, and 4, which are the only positive values of the values array. And similarly, on the bottom, suppose we have an array of staff names, and some of which are empty strings, then we can say that valid names is, or we can filter staff names by only keeping those whose name is not empty. So essentially, whatever you return in your function, if you return true, then that means you're keeping that element. If you return false, then you are not. Okay. Any more questions? Yes. Oh, okay. We'll get to that soon, actually. But essentially, triple equal sign, they have to do with references. So normal double equal sign in JavaScript, it doesn't, let's say we have the integer 2 or the number 2 and then the string 2. If we use a double equal sign, it'll show that the number 2 is in fact equal to the string 2. So it doesn't really think about the types. It just converts it automatically, and then it says that it's equal. So if we want to make sure that the number 2 is different from the string 2, then that's where we use triple equals. Thank you. Okay, but before we talk more about triple equals, we have a car. So what I talked about before, we had a few primitive data types, none of which is car. And so one thing how we get about that is if we have more complex things which we want to represent, we can then use objects. So an object is a collection of name to value pairs. Now this looks a lot like perhaps the CSS rule set. It could also look a lot like Python dictionaries. And it actually just functions really similar to a Python dictionary. So it has name value pairs. So make is your name, and then its value is 4. So you're basically assigning all of these pairs, and you're saying that the aggregation of that is some object. And for objects, it's a little bit different from accessing properties in arrays. You can also access the property by using the dot. So this is saying if you want my car.model, that gives you the model value, which is Mustang. But also similar to arrays, you can access it using the bracket notation. Just put whatever name you have in string form because it is interpreted as a string. Okay. And also we have object destructuring. So first, we can just look at an example without object destructuring and see why object destructuring would be better in some cases. So on the bottom here, like I talked about before, we are accessing the object's properties. So we are using the dot or the period to get the make and also the model. So now what if we have a bunch of things that we want to get? What if we want to get the make, model, and year? Or just the make and model. Then we can use object destructuring. We can just do a clean one-liner here and say const in curly braces, whatever you want to get out of your object equals my car, and then all of those variables in the curly braces, they'll be stored with the actual value. And so this would be very useful if, let's say, you have a very big object with a lot of name value pairs, and you want to get a lot of name value pairs out of that object. Then you can make a very quick one-liner instead of having to do the dot or the bracket notation to assign it a value or assign it to a variable every time you get the value. So this is very clean and simple compared to the previous version. Okay, and also you can use objects like any other variable. You can even put it in arrays. Like arrays, they can have mixed types, so that's also fine. And you can use it on functions like filter and map. So in this case, you're going through my cars, and then you're running this filter that only gives you back the cars whose color is red. So that's what the last line means. Okay, and now we're getting to equality, the triple equal sign. So we use the triple equal sign to check if two primitive variables are equal. So in this example, we see that the number 2 is in fact equal to the number 2. The number 2 is not equal to the number 3. The strings 2 are both equal, but the number 2 and the string 2, they are not equal because they are not the same primitive variable. Okay. But then for arrays and objects, we have that even if array 1 has the exact same elements as array 2, when we run the triple equals, operator or comparison operator, it gives us false. And then even for objects, if we have objects with the same name value pairs, we'll still get false if we run a triple equals operator. And the reason why that happens is because object variables are references. So they point to the location in memory where everything is actually stored. So you can visualize it like this. Person 1 is pointing to some location in memory that stores that there is an object with name locates. And then similarly, person 2 points to another object whose name and value pairs are equal, but it is stored in a different memory location or location in memory. So what we are checking is we're checking the references, so where they point to. And since we've created these two people separately, even though they have the same value, they have different references. And so that's why we get that the triple equals comparison operator gives us false. Yeah, so since they're stored separately, their references are different. And similarly for arrays. So like for arrays, instead of like the object box, you can say that that is an array with like a list of something. And so you'll see that array 1 points to a different location, while array 2 also points to a different location. Okay, so now how do we copy arrays if we can't say array equals the other array? Well, we can use the spread operator. And now the spread operator basically just copies everything into the new array. So on your left or right, the code over there, it's by using the 3 dots in front, you're going to copy the first array, which is 1, 2, 3, onto this new array called copy array. And then, as usual, you would always have like the brackets to denote that this is an array. And similarly for objects, you'll have the curly braces. And I believe this is called a shallow copy. And yeah, you can also just manually copy, but it's far easier to do it this way. Okay. And like I said before, we don't use double equals because double equals allows 2 to be, or the number 2 to be equal to the string 2, because it automatically just makes sure that the arguments are of the same type. So even though the number 2 is different from the string 2 in type, it automatically forces their types to be similar. And so it just cares about the value. So usually I would recommend you to use the triple equal sign because it checks for also type. And this could be important. You could run into some issues if you get that your number is equal to your string, because sometimes you might want to use a number, but you don't know that it's a number because you checked it against, or you use the double equals to check it against a number, but it could be a string. Or this might not make sense, but you'll understand later. Okay. And then one thing that we also have in JavaScript is classes. So if you want things to share the same behavior, you can use classes. In this example, we have a class called rectangle, and then every class has a constructor, which shows you how each instance is made. And an instance is basically a version of that object, filled in with like all of the arguments needed, like the width and the height. So you can have a 3x7 rectangle that could be an instance of this class called rectangle. You can have a 4x8, and those would all be instances. So now what this constructor is telling is saying that for this instance, I'm going to set its width to whatever it gave me, and then its height to whatever it gave me. And it also has these instance properties. So for example, each instance will now have a width and a height. You can't have a rectangle without a width and a height. And each instance also has the get area function. So, for example, a 4x8 rectangle can then call the get area function to return the area as 32. And you can access these instance properties by using this. So for our get area function, for example, we want to get the width and the height in order to multiply them and return the area. So to get the width and height that is specific to whatever instance is using this function, we're going to have to use this dot. And yeah, we have also methods like the get area method, and these exist in every instance of the class. And you can just call it from using the same syntax below. So on the bottom, we created a new rectangle. How we create new instances of classes is we use a new keyword in front of whatever the class is called, and it input the parameters needed in the constructor. So over here, we created a 6x8 rectangle. And then to call the function get area, we use a dot operator. And so we call get area on the rectangle that we have created. Okay, and one last thing, we have two functions that are going to be very important in the game lectures. These are called set interval and set timeout. Now for set interval, this repeatedly calls a function with a delay between each call whenever you start it. And it returns an interval ID, which can then be passed to clear interval ID to end this loop. And then for functions, you have to input whatever function you want to call repeatedly. We want to input also a delay a delay between each function call, and then also all of your arguments that you need in your function. And similarly for set timeout, you also have an interval ID and similar arguments, but the main difference is that instead of calling things repeatedly, you are now setting a timer that executes a function once when the timer ends. And so, yeah, this returns the interval ID, which you can use to put into clear timeout now in order to cancel the timer. And it has similar arguments for that. Okay. So in summary, we learned about declaring variables using let and const. Do not think about var. Var is forgotten. We also have our primitive data types. So that's Boolean, number, string, null, and undefined. And then we also learned about functions, arrays, objects, and classes. We learned about the if statements, the whiles and for loops, using the for of loop, or the more Pythonic way, or the iterating through indices. And we also learned about set interval and set timeout very briefly, which we'll touch upon later in our game lectures. Okay, and after that, we'll be having a JavaScript workshop in which you guys will be able to make a very cool game